Live?
All right.
Yep, we are.
We're ready. All right. Good morning, everyone. Thank you so much for joining. I know you probably had a really long week here at Ignite, learning tons of things. So Max and I really appreciate you joining us today at the very end for our session. So my name is Stefanie Lemon. I lead the virtual machine product team in Azure Compute.
I'm Uritsky. I lead the compute infrastructure, including Azure Boost project. And yes, we hope we saved the best for last. So hope not to disappoint you. I also have a little thing that I kind of try to figure out. So we didn't bring any swag from Azure Boost, but if you leave a review and you manage to send me your address some way, we'll make sure it's going to go to you after the conference. So the first, I would say, 20, 30 people doing it, you can receive a very nice Azure Boost mug that you'll enjoy. That's an offer from my perspective. But yes, really happy to have you guys, and we'll talk about what are we doing.
Yeah. So today we're going to talk about Azure's workload-centric approach when we're defining infrastructure. And we'll dive into the virtual machine portfolio and highlight some of the recent announcements that were made this week. And we'll also talk about Azure Boost updates and some new features. And we'll have some demos along the way that we're going to show. They're pre-recorded just because making sure we don't have any connection issues, but we'll walk through those as we go along. So as we think about designing our infrastructure in Azure, we take a workload-centric approach, which means that we start with the fundamental customer expectations, such as secure by default and resilient by design. And then we understand what the platform capabilities need to be in order to meet the needs of business-critical, cloud-native, and AI-native workloads. So in this session, we'll touch on how we've addressed these workload needs through our latest products and underlying infrastructure components to deliver industry-leading performance. Since the Build conference in May, we've made several new VM announcements in several of the categories. So these new VMs deliver improved performance as well as better price performance for many different types of workloads. So whether you're running an enterprise workload or a cloud-native workload, HPC or AI, Azure has a portfolio of virtual machines to meet your requirements. So throughout the presentation, I'll be highlighting the new virtual machines and features which are in preview, as well as a few that have been recently made generally available. And as we go through, Max is going to then highlight, and in some cases do some demos, of the new capabilities that these virtual machines have. And he'll also give you a sneak peek into some of the future capabilities that are coming next year. So first, earlier this week, we announced public preview of the EBS-v6 series VM. This VM series is designed for workloads that need high remote storage throughput and IOPS, such as databases, in-memory analytics, and data warehouse applications, just to name a few. And we're previewing in the East US region. With EBS-v6, you can get up to 192 vCPUs and 1.8 TB of memory. You can also expect performance increases with the CPU and memory bandwidth. And with Azure Boost, this VM can achieve up to 800,000 IOPS and 14 gigabytes per second of remote storage throughput with Premium V2 and UltraDisk. And so on a per vCPU basis, the remote storage performance is up to 15% higher than the prior version, and there's also up to 10% higher remote storage throughput per vCPU. So to join the preview, you can scan the QR code there on the slide or go to the announcement link to sign up. Another exciting preview announcement this week is for our D and ES-v7 series based on the latest Intel Xeon 6 processor. These VM series work well for a broad range of workloads since they're part of our general purpose and memory optimized families. They're available in the standard memory to core ratios with and without local NVMe temp disk, and we're previewing this in the East US2 region. With these VMs, we're significantly increasing the number of vCPUs up to 372 vCPUs and 2.8 TB of memory. On integer-heavy workloads, we're expecting up to 15% performance improvement. And with Azure Boost, we're going to have up to 800,000 IOPS and 20 gigabytes per second of remote storage throughput. Another important thing to note is this is our first general purpose VM with up to 400 gigabits per second of network bandwidth. So you'll have more remote storage performance per vCPU and higher networking bandwidth per vCPU. And so again, with the QR code or the link there, you can scan that and sign up for the preview. So these are the two main VM announcements this week, and now I'll hand it over to Max to share what's new and exciting with Azure Boost.
So how many people heard about Azure Boost? Just asking. OK, awesome. We're slowly getting through some community building. So in general, I would put it this way. Azure Boost is a capability that we introduced to the fleet. It's basically a major redesign of Azure fleet, or Azure Compute fleet. And as we're going to go through capabilities, I'll say some of them get exposed through the VMs that are shipping right now. Some of them will be exposed a little later. So some of these demos we will be showing will be more like, look, mom, what I can do. And so just know that that's a disclaimer. It's going to be slowly rolling out in the best quality in the version of VMs or features we enable. Now, first of all, what's Azure Boost? And what we announced with the Intel V7s is a new generation of Azure Boost. Frankly, I have this card here. You can maybe go and look at it later. Try not to take too many pictures. Azure Boost is effectively a card we insert in every compute server that goes out there. Everything, including AI, including M-Series, including SAP servers, including everything we do, including our internal infrastructure. Basically, it's something that allows us to fully standardize and offload things to a special card, so the server is optimized and isolated from the stuff we do as Azure. And it drives a lot of improvements across the board, including maintenance and networking and performance. And unlike many of the other competitors we have in the market, we really try to focus on customer experiences. So what do we bring to the customers versus Azure Boost, like, look how great the card is. Now, the Azure Boost, we don't sell it. Like, we don't give it to anybody. Nobody can buy it off the market, except for some cases somebody stole it and sold on eBay. Real story. But we usually catch it and not really allow this. And so what is new with Azure Boost? So this next generation of Azure Boost that I was just showing notes a few things. One, it has these two NICs, which are connected to a dual TOR. It basically allows an active-active. So when we talk about 400 gig, it's 200 gig ports on two different TORs, which basically allows customers to survive any unexpected issues with ports or switches or any maintenance events. And that's actually the sort of hidden gem that we kind of have here on the slide, but we didn't really plan for, and then we realized we hit the jackpot. We have so many customers complaining about maintenance. Like, I think I had a conversation with somebody this week saying, oh, I had like 4 maintenance events in 1 month. And it's impossible. Like, you guys keep updating stuff. So with Azure Boost, because we moved all of our networking stack to this specialized card, and it runs in the user space in kernel, not in kernel mode, in user space in Linux, we can actually update network drivers without causing any customer disruption. And when we announced it, we actually had customers telling us we are probably lying. So we had to take a few of customers, including gaming customers, and just do update while they were playing the game. And what they saw is a bullet slowly changing trajectory, but that's basically the entire impact they saw. And so this magic is what we really bring as a customer experience outside of the things that we do from performance and other enablement. I'll demonstrate some of the performance improvements in a moment, but the other feature we'll talk about a little later is Azure Boost Confidential Device, something we nicknamed ABCD, because it actually kind of makes sense. It's like ABCD. And so we had always a vision of confidential computing, and there is lots of customers who are interested in confidential computing on Azure. Mark Rusinovich, our Azure CTO, has been always highlighting this as a thought leadership. But it had lots of disclaimers, like, oh, if you do this, you lose performance here, it's going to be a little slower, you have some reliability issues. ABCD is supposed to solve it, and we'll talk about why. But let's get to the next thing, and demos. By the way, disclaimer, the demos are not live. I'm not as brave to try the Moscone Center wireless network. The demos are recorded. And so the first one is 400 gig. And so it's kind of very simple and very fast. Open 64 ports on one side and 64 ports on another side and pass through traffic, and you get 393. Yes, it's 400 minus tax. But generally speaking, the one thing I want to highlight is doing 400 gig NICs is nothing because everybody in the industry has it. But creating a network infrastructure that allows you to actually pass through 400 gigs traffic across the data center is real hard work. And so we work very hard with our networking team on making sure that we can go and create it as a general purpose SKU, not something that is sitting in some corner of the data center which is enabled. All of Azure data centers are revamped to support 400 gig. And so when the V7 SKUs go, they will go in every data center, and you'll be able to benefit from it from the 400 gig throughput everywhere. So that's one disclaimer. Oh, the other one important, I'll repeat it at some point. Our tool of choice for network performance is NTTCP. So we sometimes get customers trying to use ICMP as a test tool. We don't deal with ICMP too well because we don't care much, and so we drop packets. So please use NTTCP if you want to test performance of your VM. The second one is, and I think Mark Rosinich also had it in the demo because it's so cool. We reached a round number of 1 million IOPS. It's kind of, in the demo we're using 24 premium disks, or remote disks, just so people know how to repeat it. And as you could see, we actually went above, but 1 million was such a nice round number. We just said 1 million. And we can do more. We just stopped here for now. Now, for comparison, yeah, demo disappears. So for comparison, what is 1 million IOPS? If you want to do this on premise, you would need a large RAID 0 array of around 10, 12 enterprise-grade SSDs just to run this workload. And so from that perspective, it's not like I'm advertising by this versus RAID, but it means we hit the jackpot of we are not seeing any customer workloads that are blocked from moving to Azure because of storage. Like the amount of storage throughput that we allow right now is basically allowing everything to move, including Epic, including all other storage-hungry things that we used to do in the past. And by the way, in the past, the way we operated, we created a specialized hardware. We created clusters with local RAIDs to allow those customers to move. We stopped doing it. Our remote storage is now good enough. It just goes. So that allows us to go through. Stefanie?
Yep. All right. So first, to cover some of the other announcements that have been made recently, we announced preview of our latest AMD-based DA, EA, and FAS V7 series in September. And these are based on the AMD 5th generation EPYC processor. And we have them available now in preview in 3 regions. With these VMs, we see up to 35% improvement in performance and in price performance. We offer larger sizes than we've offered before, and we have predefined constrained core sizes. And with the single-threaded FA series, we also offer a new 1 vCPU size, as well as the option for having local NVMe temp disk. With Azure Boost, it drives improvements in the remote storage IOPS and throughput, and an increase in the total network bandwidth. So many workloads will see substantial gains with these VMs. Many of the workloads we've tested have seen anywhere from 25% to up to 80% improvement. So we expect many workloads will see some benefits from these, as well as the improved price performance. So you can find more information at the link and the QR code there. And we've received some great feedback from some customers on these VMs that they've been testing. Elastic, FlashGrid, and Vertigis have all provided some testimonials about what they're seeing. So Elastic, for example, is seeing up to 13% better indexing throughput compared to their previous generation on the v6 VMs with Elasticsearch. FlashGrid is benefiting from the higher network bandwidth, and they're getting better performance of the FlashGrid cluster with Oracle RAC. And finally, Vertigis, which provides geospatial solutions, they're seeing higher performance and faster client-side response times with the single-threaded FA series, as the ArcGIS Enterprise application and other applications that they run tend to be CPU-bound. So now I'd like to show you another benefit that we've seen in a workload test using the DADS v6 and v7 VMs. So we did code under test. That's Microsoft To-Do application that was pulled from GitHub. It uses React.js, Node.js, MongoDB, and AKS. So the sample code was used to deploy 2 near-identical environments. The only difference is the underlying AKS node in the deployment on the left is using the 4th generation AMD EPYC-based the D8 ADS v6, while the deployment on the right uses the 5th generation AMD EPYC, which is based on the D8 ADS v7 VMs. So the load was applied to both environments using the Azure Load Testing Service, which is a fully managed service that allows you to simulate high-scale traffic for your applications. And so after the test completed, you can see on the left that the v6 implementation was able to process 33.56 million requests, while the v7 implementation on the right was able to process just over 45 million requests. So this is a 34% improvement in the number of load requests in the same duration of time. We also see that the v6 implementation on the left has a 90th percentile response time of 502 milliseconds, which is compared to the 300 milliseconds for the v7 VMs, which is a 40% reduction in the response time. So this is just one example, but we expect that customers will see significant performance on a variety of workloads. We expect these VMs to be generally available very soon, so keep an eye out for the announcement. For cloud-native workloads, Cobalt 100 is at the heart of our Azure Compute innovation. It's been about just over a year since we introduced these VMs and had general availability, and we've seen tremendous customer adoption across a number of industries. So you can see a few of the workload performance gains shown on the right-hand side there. But I'd like to highlight a few customer success stories. With Databricks, they're running complex data analytics and accelerating their machine learning workflows with these VMs. Elastic is driving innovation and cost efficiency by running their AI-powered observability, security, and search solutions on these VMs. And they're seeing better throughput and up to 37% improved performance compared to our previous generation ARM-based VMs. Snowflake's another one who saw over 20% performance gains compared to the previous platforms, and they transitioned from x86 to ARM, but had a very smooth experience. And then finally, Amadeus, which is a leader in travel technology solutions, they've deployed Cobalt in production, and 90% of their shopping engine runs on Cobalt 100 VMs. And they cut their response times by 8% while processing 2 billion daily transactions. So these are just a few of the success stories. We have others that are available on the web. And one other thing that was announced this week, early in the week, was the Cobalt 200, which is now running in our data centers. And if you want to learn more, you can read the blog post at that link right there. And these will be available for customers next year. All right, and finally, I'd like to let you know about 2 new vCore customization features. The first feature allows you to disable the simultaneous multi-threading. So if you want to run your application with a full core, you can do that with this feature. And then with the other feature is called configurable constrained cores. And this allows you to choose any number of vCPUs for any given size. So that'll allow you to reduce the number of cores while still having access to all the memory and I/O resources of that VM, which may be beneficial in helping you reduce any software licensing costs that are done on a per vCPU basis. So these 2 features are available now in preview. for the entire Azure VM portfolio where it applies. So if that's of interest, you can check that out at the link or the QR code. So now over to Max with another technology announcement that was done here at Ignite.
Yeah, so first, before I get to announcement, a personal story. Around, I would say, a year ago, there was a few folks that we work with pretty closely in OpenShift, which is, as you know, shared initiative between Microsoft and Red Hat, that contacted us and said, well, we would love to bring our virtualization stack to Azure, but your performance is kind of bad. And there was actually lots of customers who were lined up for this, and we went and said, okay, you know what, let's use some of our Azure Boost infrastructure improvements and see if that can help. And so as of right now, we are happy to announce that it GA'd during Ignite, and so now we're allowing Red Hat customers using Azure Red Hat OpenShift to go and move their workloads to Azure. And it's using V6 VMs. I'm not going to expose actual performance data that's still being in works, but basically they found it's efficient and appropriate from customer perspective. It's better than on-premise, and it's pretty close to what the bare metal numbers are generally from their perspective. Now, we'll talk about why little and like how they leveraged, and we talk about the basic drivers that we want to recommend to customers when we get to the drivers section. But general, this is the beauty of what we're doing in the fleet. We're allowing workloads that never could be able to run on Azure to run on Azure right now. And given, of course, amount of love to VMware licensing, we have quite a few customers who are basically looking to adopt it and move into Azure right now using ARO. Now, in general, what OpenShift virtualization is bringing, they're talking about 40 to 60% improvement compared to on-premise. And this is effectively going to be integrated with Azure sales motions. And so you can actually go and use a QR code to sign up and learn more. I'm not going to, there was like, I think, 4 or 5 different special sessions for ARO. But the Azure Boost part, I don't think a lot of people realized. And this is where the power of V6 VMs with Azure Boost is coming from.
OK. Oop.
No.
Now we're going to talk about storage.
Yeah.
All right.
No dropping the mic.
I know. OK, for AI workloads, we know customers need faster access to their data. So for storage-intensive workloads, the new v4 L-series VMs provide the required capacity and performance with the local NVMe disks. These VMs have significant improvements in CPU performance and remote storage performance as well. We have new sizes, both smaller sizes as well as larger sizes, with the largest sizes being 96 vCPU and enabling up to 23 terabytes of local disk capacity. And these also are able to do 6.6 million IOPS. The new LAOS v4 family, which is really targeted for dense I/O workloads, offer 3 times larger local disk capacities per vCPU and 2 times the lower cost per terabyte of storage than the previous generation, the LSV3 and LASV3. These VMs also have improvements in networking and remote storage performance. And so your data can be moved quickly across the network or to the Azure backend storage. Elastic is one customer that has seen significant performance improvement with these VMs, up to 30% better throughput with the LAOS v4 versus LSV3. So now Max is going to tell you more about how we deliver that storage performance.
So outside of the networking throughput, networking bandwidth improvements that we've seen or working through, and that's the 400 gig stuff that we talked about, there are 2 things that we try to invest in across Azure from storage perspective. One, we are trying to move everywhere from SCSI to NVMe. And so just generally, if you have a SCSI VM running on Azure, try to figure out how to move to NVMe, because that's the future from our perspective. And the reason we are doing it, we are trying to standardize the protocols. We are working on some of the newer capabilities, including NVMe over Fabric, including other things that allows us to disaggregate and basically create a situation where customers should not really care where the storage is. To some extent, I think we demoed it, build, like this NVMe and abstraction layers that you see even on the local storage allows us to preserve customer storage, even if VM dies or kind of gets destroyed, because effectively this is a remote or local disk used as NVMe disk, basically same as remote disk. And so it allows us to play all sorts of games when we do this. And so the way this looks like, we usually have like Azure managed disks, which is premium V2 or just premium disks or router disks that we try to accelerate, and you've seen it in the EBV6 performance. And we also have the Azure Boost SSDs, which is the local disks, which we all proxy through the NVMe interfaces and try to isolate from the VM boundaries. So this is how we are trying to make sure that this is as seamless from customer's perspective and allows us to do the right things from customer performance and experiences. And so I'm going to highlight one of the customers or partners that we are working with, which is Silk. Effectively, what is going on right now, and we kind of see it in the market, there is a lot of interest in AI inferencing platforms. So training, big GPU data centers. As you all know, we work pretty closely with very large customers like OpenAI and many others being announced. But then there is lots of enterprises that want to go and say, okay, how do I leverage AI? How do I start building something that allows me to have a customized models that I run for myself and that I own because I know my business. Like some generic ChatGPT or doesn't really know what I need. What I need is to build models that are optimized for me. I'll give an example of something we use in Microsoft. Because of all the data center infrastructure, we have so many fiber cuts you wouldn't even imagine. It's around it's in hundreds per day. And so, and it happens from everything, from people doing constructions to boats, fishing and dragging the net and basically cutting cables. And knowing where to send the crews is our internal logic that no generic AI will be able to provide. Similar for most other enterprises, that became the main thing. It's like, okay, how do I go and build my custom AI inference and infra that allows me to optimize my own tasks? And so Silk is one of the providers who is trying to build it on Azure. And what they've done is they used LA v4 with local storage, because most of the stuff is trying to optimize for local storage. And they've seen up to 50% improvement in cost for their customers. Basically, that is where the power of network throughput, staying with the latest NVMe models, staying with the latest networking drivers, is coming through and allowing them to build something that scales up. And there are more customers that we're going to, or partners that we're going to reference this way, but this is basically how this evolves on the platform.
All right. All right, the last VM type I'll talk about today is our new network-optimized VM family. This one has 3 memory-to-core ratios as well, and the option for local or using remote storage only. These VMs are best suited for real-time data analytics, high-performance file systems, network virtual appliances, and CPU-based AI and inference workloads. And so there's several improvements over the standard, D&E v6 VMs. We have the increased network bandwidth per vCPU, the ability to configure the 4 vNICs with the smallest sizes, support for up to 200 gigabits per second with the 128 vCPU size, dramatically higher connections per second, and up to 2 million concurrent connections. So, and I'd like to thank the product manager and engineers at Palo Alto Networks who have been working very closely with us on these VMs. So you can find out more details about these VMs also at the QR code in the link. And now Max will tell you more about how to get the benefits out of these new VMs.
So now I'm going to get a little deeper into networking. So I'll start from the right side. So what we've done from Azure infrastructure perspective, we basically moved to Microsoft Azure Network Adapter. Over the history of Azure, we collaborated with a bunch of different NIC providers. Mellanox is something that everybody knows about, but there was Intel as well at some point. That created a lot of dependency for us and lots of inflexibility to move to the next generations. So we moved to MANA, which is Microsoft Azure Network Adapter. Now, what does it mean from customer perspective? One, we built this I/O accelerated translation layer that allows us to translate basically the request. So it looks like it goes to MANA even though it goes to original NIC. And that works. And so most customers don't necessarily notice they're running on new hardware anymore, but they don't get the best performance. Basically, if you don't have MANA driver in your OS image, most chances you're going through the synthetic part, and you're getting basically proxy translation, which means you're not getting the performance that we actually want you to get. And so the one real advice I give to a bunch of customers that we meet with is like, please go to MANA docs, or aka MS MANA, and please make sure you integrate MANA into your OS images. We've done our part. We went and built a bunch of, or upstreamed a bunch of MANA to all known distries, and you see on the Windows and Linux list on the left side. However, lots of customers are running their own custom OSs, and of course, we didn't really go to places like CentOS or FreeBSD or any of these distries because they're well maintained or contained by their own owners. Now, the other thing that we give is we try to give a list of tools you can use to test your applications. NTCP, I mentioned already for the bandwidth and throughput testing, SOCPair for the latency. And there is a new tool that we just open sourced, which is called NCPS, which allows you to build a connection per second testing. The other thing we are doing as part of it, we're also publishing our flow limits so customers know how much they can achieve for each VM size. I will say we are very proud about the 400K CPS. By the way, it's free. You can just use it as part of network optimized. It is pretty much industry leading. And we're going to continue evolving this to reach even more throughput as we go through. And of course, what we've done is we started with the companies which are most network sensitive. And so we went to Cisco, we went to NetApp, we went to Fortinet. As I said, we worked with Palo Alto in the past. And we tried to upgrade all of their existing firewalls and virtual appliances and things they do to the new infrastructure. As you could see, all of them integrated MANA driver, and all of them have seen very significant improvements in performance. And so that's a general plea I have for customers. Many times we get a customer escalation, and they're like, oh, I'm seeing increased latency. Like, did you get the last driver? No. So please make sure that you do, and please make sure that your OS images are plugged in. And you'll see the things the other customers or partners are seeing. And now we have 10 minutes left, so we'll go through a couple of things which is more like, look what we can do. These things will be coming to VMs a little later, probably in 6 months from now. Well, I don't need to promise, or I don't want to promise on timelines because I may get committed. But there is a couple of features I'm going to highlight. One is RDMA, guest RDMA feature. So what we see is, and that's the whole networking industry moving away from TCP as a main way to do stuff. RDMA is becoming, or RoCE is becoming the main protocols to use. And it's very simple why, because generally speaking, if you look at the OS image or the driver thing, which is on the left side, the TCP IP goes from application to the TCP IP stack, to the MANA driver, to the Azure Boost card, and then gets redirected. RDMA goes directly to Azure Boost and back to directly to the VM on the other side. And so we enable RDMA data path today for storage. So today, almost all of the performance improvements you're seeing in storage are related to using RDMA in production. We're going to start exposing this to VMs. And so here's a very small demo. Just from comparison perspective, you can see that there is on the left side, there is a VM using TCP, and on the right side is a VM using RDMA, transmitting the same amount of information. And what you see is that the latency is 3 times lower than, or 2.3 times lower for RDMA. Yeah, the demo disappears too fast. Let me try to repeat it. It's too short. And then the biggest thing is you actually see 7 times less CPU usage. So effectively, if your application is using RDMA, you're not spending any CPU cycles on it, because basically it doesn't go for the normal TCP IP stack and drivers. And so that capability will come soon. Stay tuned. But something that we are working on. Another one, and this is the one where I think we wanted to keep it for the end. So whoever is patient enough to stay with us will actually see it. But that's, I would say, the biggest secret or non-secret that we announced this week. How do we evolve confidential computing? So as I said, there is lots of customers who want to see confidential computing being ubiquitous, right? It's like you can take any VM and say, now it's confidential. I do memory encryption. And so we invested a lot in making sure data in transit is encrypted. We are doing VNet encryption. We are doing storage encryption. But there is a problem, or there is an inherent problem in the definition of the TCB for confidential, where you have a TE memory. Basically, you have a memory of the VM that is within your TCB. It's your trusted compute boundaries. Then you have all this hardware stuff, like Intel, AMD, devices, NICs. And then in the middle, you have hypervisor. And so what happens is, if you want to protect against hypervisor peeking into your traffic, you kind of need to play all sorts of performance gains to make sure that this traffic is not visible from hypervisor perspective. And so what we end up doing to basically provide this infrastructure on Azure today, before ABCD, is we are creating the thing we call bounce buffer. Basically, we create a separate buffer and restricted memory where we decrypt the traffic and encrypt the traffic again. And so the customers and everybody else is paying lots of penalty for having this happening in production. So what we've done, and I'll put it this way, this is one of the things where, like, this type of things that we did takes years, because you have to work with industry on the protocols. You have to agree on what is the standard. You have to work with the CPU providers to implement this in the new CPUs incoming. And so I think that journey took us around 3 to 4 years to get here. But what we've done is we basically work with AMD and Intel on creating specific protocols that allows us to extend TCB boundaries to the Azure Boost. And it's not proprietary. It's something that generally probably other competitors can do. But of course, I assume it's going to take them way longer. As you could see from the quote, both AMD and Intel has been working with us and testing it, and they feel very excited about this feature, because this is when finally all the investments in confidential computing are coming to become mainstream. Now, because what you do right now, you can effectively say, OK, Azure Boost is part of the TCB. You basically skip the hypervisor part, and you skip the sort of the translation part. You don't need the bounce buffer. It just goes through, and then everything seems to work together. As I said, I'm kind of pretty happy about the name ABCD, because it is kind of, people go with like, yeah, duh, of course we should have done it a long time ago. It took us a long time to get here, but I think that's the one we are really excited about. This is where our vision actually going to come through. I have a couple of demos to show that, and yeah, by the way, before the demos, so here's without confidential device, which is effectively using shared buffer for the bounce buffer encryption. And here's this one on the right side of this picture where we have an ID encrypted PCI link that is just keeping all the data encrypted and within the TCP without exchanging keys and doing all sorts of weird stuff. We don't really have a cool demo for this yet because we are still working on it. It's going to come soon. But the demo right now is effectively just this, like when the VM, or basically when computer wakes up, it needs to look, it's looking for the trusted device on the PCIe. It recognizes Azure Boost as a trusted device. And basically says, OK, I can talk to you in the TIO protocol or TDS protocol, and because you're trusted device. And then when the VM comes up, it just going and pumping traffic without using the bounce buffer. So I know it's a little too deep or kind of under the covers, but that's basically what we are doing right now. And unfortunately, I couldn't bring the PCIe analyzer to show that the data is actually remaining encrypted, but we have an actual snapshot of PCIe analyzer traffic, which we validated ourselves with the provider that all of the flow remains confidential and there is no decrypted or encrypted traffic that we can look at. Basically, it creates a situation where you can hack. You shouldn't, but you can hack Microsoft hypervisor. You will not be able to see any of this data, basically. So that's the one we feel really passionate about because I think this is, as I said, it took us quite a few years, and we see it as a breakthrough in bringing confidentiality to the rest of the fleet. Okay, recap.
Yeah. All right. Well, that's all the updates we had for today. And so hopefully, now you have a better understanding of how we take a workload-centric approach to defining our infrastructure, the types of VMs that are available for a wide range of workloads and that will benefit you, and then what Azure Boost is doing under the hood and how that all works together to bring the performance and security and reliability capabilities to your workloads.
And if you want to remember two things, move to Mana and move to NVMe. Don't stay with SCSI and on I would say DPDKs from previous NICs. That would be the two recommendations.
Yeah. So thank you. Thanks for your attention. Any questions? We can take those too. So.